So we're going to do 4.3 logarithmic functions. So logarithmic functions, the definition of a logarithmic function just simply means that you let a be a positive number where a cannot equal 1. The logarithmic function with the base a is denoted by log base a. It's defined by log a, which is defined by log ax equals y. And then this is how you would rewrite a logarithmic form to an exponential form. So log a of x is the exponent to which the base a must be raised to give x. So I would definitely make sure you know this. The logarithmic form is log base a of x equals y. Recognize that a is always your base, y is your exponent. And then your exponential form, whereas a is your base, and y, notice where it comes as the exponent. So we're going to look at some examples next. Okay, so example 1 says express the equation in exponential form. So that means that we take on the fact that we know that our base is going to become our a value, and then the exponent, which is our y position, is going to become our exponent. So recognize that this is the base and this is your y value. So when rewriting this, we have 8, which is our base, to the 2/3 power equals our y, which is 4. So it kind of makes like this little circle here. So noticing just how it makes the form of a circle. Example 2, we're expressing the equation in logarithmic form. So we kind of make the same rotation here. So recognizing that 2 is our base, and the y value, which is 1 to the 8th, becomes the exponent. Or sorry, our -3, which is our exponent, becomes what it equals to. So rotating it, we have log base 2, because that's our base, 1 over 8 equals our exponent, which is -3. This is the properties of logarithms. The properties of logarithms, if you have log base a of 1, that will always equal 0. Log of a will always equal 1. Log a of x will always equal x. And a to the log of a of x will always equal x. So just knowing some of these rules will help you to not have to do some changes with your logarithms to exponentials later on. Okay, so 3 says evaluate the expression. Log of 3 of 127 is going to equal what? So that just simply means we want to go ahead and just think about what this will equal. So I like to put a question mark when I said I'm equal to each other, just so I know what I'm looking for. So if I were to do the rotation here and change it to an exponent, I'd have 3 to what power equals 1 over 27. So I know automatically that 3 to the -3rd power gives me 127. So that's what it would equal. Then when I look at B, I have log base 81 of 9 equals what? So ultimately, I want to know 81 to what power gives me 9 by changing it to exponential form. So I know that that question mark is going to equal a half. Let's look at C. C requires some different rules here. So I can kind of look at this to either identify my rule that was from the previous slide. So if I go to the previous slide, which rule does this look like? This looks just like rule number 3. So my a value in this case is 4. And then the exponent is going to be 5. So I know that this formula has to equal my x value, which is 5, based on the rule, which is number 3. Let's look at D. We have 6 log of 6 of 7. Well, when I look at this rules, my rule 1 through 4, this looks very similar to rule number 4, which equals our x value. So in this case, I have the value that our x would be is 7 because all of the information 6 log of 6 is the same. So that means this value would equal 7. Rules from the previous slide of 1 through 4 will help you to identify what goes on in these setups. All right, let's do inverse of logarithms. So when we think about inverses, that just means switch x and y. Anytime you see inverse, it means switch x and y. So I have f of x equals 2x, which is the same as saying y equals 2 to the x power. Switch x and y, so I have x equals 2 to the y power. I'm now having to change this to a logarithm from exponential, which means my 2 is my base value, and that should always equal my exponent, which is y. So I'll have log base 2 of x equals my exponent, which is y. Then I look at b, again, same concept. I have y equals log base 7 of x. I'm having to switch my x and y's because I'm taking the inverse. So I have x equals log base 7 of y. I need to write this logarithm in exponential form so I can solve for y. Well, I know that 7 is my base, and my x is going to become my exponent, so this one takes on the rotation that I need. So I have 7 to the x power equals y. Letter C is a little different. So we have y equals 7 the x minus 3 plus 4. I have to switch x and y. So I get x equals 7 y minus 3 plus 4. Then I need to go ahead and move the 4 to the other side. So I'll subtract 4 from both sides. It's just so I can get everything with an exponent by itself. So I'll have x minus 4 equals 7 to the y minus 3. Then from here, I can go on and take on changing this exponential form into logarithmic form. So my base here is 7, which means the y minus 3, which is my exponent, is going to be what I end up equaling to. So I have log of base 7, x minus 4 equals y minus 3. From here, just remember this is your base, makes this rotation here, changes it to log. From here, I can go ahead and solve for y by adding 3 to both sides. So I get y equals log base 7 of x minus 4 plus 3. Okay, so graphs of a logarithmic function. The domain here, y is going to have to be greater than the vertical asymptote, or y is going to have to be less than the vertical asymptote. The range is always going to be all real numbers, so negative infinity to positive infinity. The vertical asymptote is always x equals h, which is a horizontal shift. So I'm going to write exactly what your equation would look like. So you'd have f of x equals a log of base b times x minus h plus k. So remember that your vertical asymptote is always x equals h. So it's always the opposite of what h is. So we're going to look at how we graph these items. So example 5 says graph the logarithmic function, state the domain, range, and vertical asymptote. So looking at this, some key things that I want to highlight is this -1. So I want to find out what my domain is, my range, and the vertical asymptote. So the range with logarithms is always all real numbers, so negative infinity to positive infinity. My domain of my vertical asymptote, remember my vertical asymptote can be found by identifying what my h is. Remember the h is always opposite, so since it's -1, that means that my vertical asymptote is x equals 1. And because there's no negative out here in front of the log, I know that my domain is going to go from 1 all the way to positive infinity. So let's go ahead and just plot our vertical asymptote, which is at 1. So that means that at this value here is my vertical asymptote. And we'll go ahead and create an XY table here. Let's look at our calculator of how we graph this. So I plug in my y equals equation. Y equals, how we go about this, we're going to go just math. So you want to go to math. You're going to scroll all the way down until you get to the letter A with the little arrow. You see how it says log base? Because we have a different base than 10, we have to do log base so we can put in our base. So log, our base here is 2. Scroll over so we can get inside of the log, which is going to be our x minus 1. Scroll to the right outside of your parentheses and you're going to put -3, and we're going to graph this. So notice how our graph looks. So when I click second graph and pull up my table, notice how all the values that are above 1 are the values that we want to use for our table. So I may choose 2, 3, maybe 1.5, 2, 3, and maybe up to about 5. So in my X table, I'm going to do 1.5, 2, and 3. So I find out that I have -4, -3, and -2. So when plotting this graph, I'll have x is 1/2, down 1, 2, 3, 4, and then 2, I'm at -3, and then at 3, I'm at -2. So it tells me that my graph does something like this. Now you have everything listed.